I'm Michael, and today we're clearing up a very common confusion: how to properly size a fuse between your lithium battery and inverter. Now, I've seen a lot of people say something like, if you have a 200 amp hour battery, just use a 200 amp fuse. That sounds simple, but honestly, it's not correct. People usually mix up three different things: battery capacity, amp hours, battery BMS limits, and the actual job of a fuse. So in this video, I'm going to break it down step by step using a real example: a 12-volt lithium battery connected to a 2,000-watt inverter. By the end, you'll know exactly how to choose the right fuse, and more importantly, why it matters. First, let's fix the biggest misunderstanding. A fuse is not there to protect your battery. Its main job is to protect your cable. That's it. If something goes wrong, like a short circuit current can shoot up extremely fast, especially with lithium batteries. We're talking hundreds or even thousands of amps in a split second. If your cable can't handle that, it will heat up, melt insulation, and in worst cases, start a fire. So the fuse acts like a safety switch. It blows early and cuts the power before the cable gets damaged. That's why choosing the right fuse is critical. You should never pick a fuse based on battery amp hours. Instead, your fuse size should be based on how much current your inverter will pull from the battery. Not the battery size, not the label, only the actual load. To make this simple, let's take a real setup: 12-volt lithium battery, 2,000-watt inverter. We're going to use this setup throughout the video and calculate everything step by step. First thing, we look at the inverter. In our case, it's rated at 2,000 watts. That means, at full load, it can supply a 2,000-watt device. But here's something important a lot of people forget. Your inverter is not 100% efficient. Some energy is always lost as heat when converting from direct current to alternating current. Let's say this inverter is about 87% efficient. So the battery actually has to supply more power than 2,000 watts. We calculate it like this: 2,000 watts divided by 0.87 equals around 2,300 watts. So now, instead of 2,000 watts, we use 2,300 watts as our real power demand. Now we convert that power into amps. Formula is simple: power divided by voltage. So, 2,300 watts divided by 12 volt equals about 191 amps. You could also use 12.8 volt, but in real life, voltage drops under load. So using 12 volt gives a safer estimate. So now we know the inverter can pull roughly 190 amps from the battery at full load. Before moving forward, we should check if the battery can handle this. Let's say the battery management system is rated at 200 amps. That means we are getting close to the limit, but still within range. There's only a small margin left, so this setup is okay, but not something you want to push beyond full load for long periods. Now comes the fuse sizing. We don't pick the exact current value. We add a safety margin so the fuse doesn't blow during normal use. Standard practice is 25% extra. So, 191 amps times 1.25 equals about 240 amps. Now, fuse sizes come in standard values, so we round up to the next available size. That gives us a 250 amp fuse. Important rule: always round up. Never go lower than your calculated value. So for this setup, 2,000-watt inverter, 12-volt battery, around 190 amp draw. You should use a 250 amp fuse. Now this is where most people make a serious mistake. Cable problem. Let's say your inverter comes with cables. In many cases, you'll see something like 35 square millimeter cables. Sounds good, right? But here's the issue. Those cables might only be rated for around 170 to 175 amps. Now remember what we calculated earlier. Full load current equals around 190 amps. Recommended fuse equals 250 amps. See the problem? If you keep those smaller cables and install a 250 amp fuse, your fuse will not protect the cable anymore, because the cable will overheat before the fuse blows. Let's say you only run a 1,500 watt load. Quick calculation. 1,500 watts divided by 0.87 is approximately equal to 1,724 watts. 1,724 divided by 12 volt is approximately equal to 144 amps. Now you're under the cable limit, so everything looks fine. You might think, okay, no problem, but the inverter is still capable of 2,000 watts. And sooner or later, someone will plug in a bigger load. When that happens, current jumps up, and now your cables are the weak point. Here is the golden safety rule. Your cable must always handle more current than your fuse rating. Not equal, more. So, if you're using a 250 amp fuse, your cables should safely handle over 250 amps. That usually means going thicker, like 50 square millimeter cable or similar. To make it easier, here's a simple table showing how much current the battery supplies based on inverter power, assuming about 90% efficiency. It also includes a 20% safety margin and the closest standard fuse size. Now let's talk about fuse types. Not all fuses are the same. For low-voltage systems like 12-volt or 24-volt, you'll see types like MIDI, Mega, and ANL. All can work, but there's one thing most people ignore. Lithium batteries can dump huge current instantly. In a short circuit, it can go into thousands of amps. So your fuse must be able to stop that surge safely. If not, the fuse can fail badly. Sometimes it doesn't fully break the circuit. That's why many people prefer ANL fuses. They usually have a higher breaking capacity, which makes them safer for lithium setups. You'll also see DC circuit breakers being used. Personally, I don't fully trust cheap ones in high-current setups. A proper fuse is simple and reliable. Final takeaway. If you remember just one thing from this video, remember this. Fuse protects the cable, not the battery. Size the fuse based on inverter current. Always add a safety margin. And make sure your cable is stronger than your fuse. If you get this right, your system becomes a lot safer. If you have your own setup, drop it in the comments. Battery size, inverter, voltage, and I'll help you size it properly.